guys, for the most part, I've gotten those of you who turned the review, or I'm going to go back over, make sure, go through the list of people who have turned their syllabus in, and I will hand back out the homework 1-1. I have put in the bonus points from last week. I've got those put in and put in most of the, I think there's 1 or 2 syllabi that I need to just check and make sure they're who they are.
I was like, on the syllabus, can I like get a signature on there? I think I asked you that. But
Yeah, just on the back, somewhere on it.
I don't have it.
I can get you another one. But I will say, if you haven't turned the syllabus in and haven't done the homework or got it turned in yet, the win gauge will say that you have an F, because it just does not understand. Because even though because bonus is out of 0 points. And if you didn't do the bonus, your current grade, and haven't got the others in, it's a 0 out of 0. Win gauge psychologist does not know how to treat that, because you can't divide by 0. It doesn't know how to divide by 0. So it says that this is a 0%. Okay, here nor there. If you did the bonus and haven't turned anything else in, 2 out of 0, it still says division of 0. It can't do it. So even though you have earned points, nothing's been assigned yet, it says that's still a 0. Okay? Because once you get the first assignment turned in, it will fix itself, or get it turned in, I'll get it graded before the end of the week. It will fix it, but this is a heads up.
So is it going to say 0 or win gauge at all times?
No, but it's just saying it's trying to divide by 0. Because it says, because bonus, I put it in out of 0 points. And if you hadn't got any other assignments in, it just sees it 0 out of 0. Because once that first assignment in, it has points totaled.
Okay, my win gauge says I have a 90 this class.
Yeah. So 0 out of 0.
Yeah.
Because it's adding 0 points to the total. Yeah. And again, whenever you look at, and she looks at the assignments, have her check how many points it's out of. Because simple points, so bonus is adding 0 points, and you miss 0 points. So you didn't miss anything. Because simple points for each assignment that's added, the point value that it's worth gets added to the total number of points. And then the points you earned adds to your points earned. So if it's out of 0 points, your total, the total number that you missed, isn't going up. So if we've assigned 50 points and you've earned 49 of them, that's your current score. If I put bonus in, it's out of 0 points. So the total number of points that you can receive is still what? 50 plus 0 is 50. But you earned 2 points from the bonus. 49 plus 2 is, your score goes up, but the total number of points that you receive that it's out of is not. So you didn't do the bonus. So you earned 0 points. 50 plus 0 is still 50. 49 plus 0 is still, even though you got a 0 on that bonus, it wasn't out of any points, it's not affecting your score. But currently, if the only thing that's in there is the bonus, it sees 0 over 0. So as soon as you put the first assignment in or turn your assignment in, it will go back to what it should be. What we started yesterday was our transformations. So f of x for each of these here. We had a, h, and k, and we talked about some of these transformations yesterday. The first ones we talked about was vertical translation. And that connected with our h. sorry, k. And that was our up or down. It's how far it moved the function up or down. And k was exactly what it looked like. So if it was positive 3, it moved up 3. If it was negative 3, it moved down 3. Then the next one we had was horizontal translation, which was our left or right. And our horizontal translation was the opposite of what we thought. Because when we have something inside those parentheses or absolute values like x minus 2, it looks like it should be 2 units to the left, but it's actually 2 units to the right. It's moving in the opposite direction of what we think. Next one we had was the reflection across the x-axis. And we know we have a reflection across the x-axis if A, the number or sign connected with A is negative. If that is negative, if A is negative, it's a reflection across the x-axis. And we looked at problems with all three of these here. These are the main three that we looked at yesterday. And where we ended was vertical stretch and shrink. Now we consider these functions to have a vertical stretch if A is greater than 1. And we say that we stretch the function by that amount. So if A is greater than 1, it's going to be a vertical stretch of that amount, or by that amount. And it's a vertical shrink if A is between 0 and 1. If A is between 0 and 1, it's a vertical shrink. If A is greater than 1, it's a vertical stretch. Yes. Now we're talking about the number, not its sign, because if A is negative, we're talking about a reflection. We look at the value between 0 and 1, greater than 1, to determine if it's a vertical stretch or a vertical shrink. So let's look at some of these here. So again, we still wanted to determine which parent function it belongs to and describe the transformation. So at the first one here, g of x is equal to 2 times the absolute value of x. Well, it kind of already gave us what function or parent function it is. 0 is less than A is less than 1. So if A is between 0 and 1, then it's going to be a vertical shrink. Okay. No, you're good. So this first one here, it's a part of the absolute value. Now, if we compare it to the general form, A, absolute value of x minus h plus k. There we go. We have nothing added to the end, so k is, we do not have a value for k, so that means it's not moving up or down. There is no value connected with H, or an H's spot, so there is no movement left or right. Now we do have a value for A, and the value for A is 2. Is that greater than 1 or between 0 and 1? Greater than 1. Since A is greater than 1, we can say that our transformation here is a vertical stretch of 2. Because when we talk about stretch and shrink, we describe or say how much is being stretched or shrunken by. So here we have a vertical stretch of 2. That means each of the y values is going to increase by a scale of 2 faster, which means it's going to get skinnier. It's going to increase along the y-axis faster. We are stretching it along the y-axis. So if we look at the graph, that out. Math. So this here is the absolute value function, the parent function. And we're applying this vertical stretch of 2. So we're saying 2 times the absolute value of x. And as we can see here, it is increasing faster. It's going up the y-axis faster. Questions on this here? Any questions on this so far? If we look at this next one, h of x equals 1/2 x squared. So what's its family? Be a quadratic. And the main reason we know it's a quadratic is that x squared, that power of 2 connected with our x. Sometimes inside the parentheses, sometimes it's connected straight to the x. Now, if we look at the general form for quadratics, a x minus h squared plus k. We have no left and right movement because we have no parentheses, no place where that h has a value. Same thing with k. It's not moving the function up or down. But we do have a value for a. A is 1/2. The number that's taking the place of a that's in that spot is 1/2. So, yes.
Above the x is that what numbers? Like above the little letters.
Right here? 2. 2. It is a 2. So it's taking the place of a is 1/2. Now, is 1/2 between 0 and 1 or greater than 1? Is 1/2 between 0 and 1 or greater than 1? 0 and 1 is 0.5. 0.5 is indeed between 0 and 1. So since a is between 0 and 1, it's telling us that this is a vertical shrink of 1/2. We're saying that the y values are going to increase half as fast as they normally would. We are stretching it out. It is condensing along the y-axis. So again, I'm going to look back at the of 1/2. If we look at the graph, x squared, the parent function, we get this U-shaped graph. Now 1/2 x squared, we see here that it's opening wider. It is increasing slower along the y-axis. So we call it a shrink because and we're thinking of it up and down, we're shrinking it down, it's getting wider because it's condensing down closer to the x-axis. And the bigger that value is, or so the smaller this is, if we said this graph is going to increase wider and wider because it's increasing slower and slower by that amount. Questions on A or B? Let's look at number 5. G of x equals 3x. Linear, constant, absolute value, quadratic. Linear, it's going to be attached, it is a line. So we look at the three forms because quadratic's going to have that square, that power of 2, that exponent of 2. Absolute value is going to have absolute values. Linear is just going to have that x to the first. And we talk about higher degree polynomials, we look at the exponent attached to it, and especially the one with the biggest exponent. Here, 3x, the variable with the biggest exponent is just x to the first. X to the first is considered linear. Even if we did have an x squared term and an x, the x squared term is our quadratic term. X is our linear term, this equation of a line. A, H, and K. We don't have a value for H and K again, but we do have a value for A, which is 3. Since we do have a value other than 1, so vertical stretch or vertical shrink. Is it greater than 1 or between 0 and 1? It's greater than 1, so it would be a vertical stretch of 3. Now, is that value of A, that 3, positive or negative? Positive. So would we have a reflection across the x-axis? No. If it was negative 3x, we would have a reflection across the x-axis because the 3 is negative. Not specifically because it's 3, but because it is negative. And then we would have a vertical stretch. Any questions on how this is working? Yes? Kind of? Right. Because the biggest thing when we're looking at this here with A, H, and K, and the reason I keep writing it is A has 2 main transformations that are connected to it. Vertical stretch or shrink, or reflection across the x. And it's seeing which one of these does it categorize or does it satisfy? Vertical stretch or shrink between 0 and 1, greater than 1. If A is 1, it doesn't matter. Not changing a thing. If we see that that number for A is negative, it's a reflection. If it's positive, there is no reflection. Because we're looking at it and how it relates to A, H, and K. Is something happening at K? Is there a movement up or down? Are we adding something to it? If there is, we have that transformation. If it's not there, it's not happening. We're not applying it. It's not been applied to it. Like if we look at the next one, h of x equals 3/2 x squared. Well, the x squared tells us it belongs to which family? Quadratic. It's a quadratic function. Now, if you, especially rewriting this helps, having that a parentheses x minus h, close parentheses, squared plus k helps. Line it up and see what's where. Write it. If it does not help seeing that, don't. Because if we look at this here, inside, do we have parentheses at all written with our h of x equals? No. So there is no value of h. There is no movement left or right because it's not there. Is there something being added to it? Because we have the square, yes? Do we have anything added to it for our k? No. So is there a movement up or down? Because there is no value of k. So we don't have either one of those transformations. But we do have a 3/2 with a, yes? A has 2 transformations, yes? One of them is reflection across the x-axis. But if it's reflected, that value has to be what? Negative. Is it negative? No, so there is no reflection across the x-axis. We're not looking at the number specifically. We're looking at its sign for reflection. Now it does tell us it's 3/2, which means it's going to be a vertical stretch or a vertical shrink. It's a stretch if it's greater than 1, shrink if it's between 0 and 1, yes? 3/2, is that bigger than 1? If we want to check, we could say 3 divided by 2, which is, so this would be a vertical stretch of 3/2 or 1.5. So it's, yes, if it's a vertical shrink, it is between 0 and 1. If it's a vertical stretch, it's greater than 1. Let's look at number 7. C of x equals 0.2 times the absolute value of x. Well, that kind of gave away which group it belongs to. Absolute value. A times the absolute value of x minus h plus k. Again, we don't have h and k. We don't have a value in either one of those two spots. So there is no movement up or down. There is no movement left or right. But we do have a value for a, yes? 0.2. 0.2 is positive, so is there a reflection across the x? No. So we go to vertical stretch or shrink. Is it greater than 1 or between 0 and 1? It's between 0 and 1, which means we have a vertical shrink of 0.2, because we specify how much the function is being stretched or shrunk by. Now, in some years I've had, can we just condense it to just stretch or shrink? Unfortunately not, because there is such thing as a horizontal stretch and shrink. So we do need to specify which one it is. Questions on these so far? All right. Are you ready for the next one? You're good? Mm-hmm. Okay. Identify the family to which this function belongs and describe the transformation. So V shape. So that would be what? Mm-hmm. Absolute value. Belongs to absolute value functions. Because that's UE. And if we look at the function here, 2 times the absolute value of x plus 1. Absolute value of x minus h plus k. Do we have a value for h? No, so that means there's no left or right movement. Do we have a value for k? Yeah. And it is? 1. So that means we're moving up or down 1. Up 1. Because it's plus 1, it's up 1. And up to this point, that's been it. We just moved it up 1 and we're done, yes? Well, does A have a value? Yeah, A is what? 2. Because there's nothing that says that we can't have more than one transformation being applied. So here we have another. So we do have a value for A. A is positive or negative? Positive, which means there is no reflection across the x-axis. But it does tell me that there has to be a vertical stretch or shrink. Since A is that value is 2, it's bigger than 1, it has to be a vertical stretch of. So the transformations that were applied to this function to get us from the parent function to this here is we move the function up 1 and applied a vertical stretch of 2. So up 1, vertical stretch of 2. That's it. Are you ready for the next one? So we're looking at this here. 1/4 x minus 3 squared. So we need to identify which family this function belongs to. quadratic. Quadratics are our U-shapes. This time, do we have a value for K? So is it moving it up or down? No. Do we have a value for H? So that means we are moving it left or right. How far? We're moving it 3, yes? Now would it be to the left or to the right? It would be to the right. Because it's left and right, it's the opposite of what we think. It is indeed to the right. It moved everything to the right 3. Because again, inside those parentheses is x minus h. So the h value is indeed positive 3, not negative. It looks negative, but it's actually positive. Left and right, if it looks positive, it's actually negative. Left and right, it's the opposite of what we think. Okay, do we have a value for a? Is it positive or negative? Positive, so do we have a reflection across the x-axis? Nope. But that does tell us that we have a vertical stretch or shrink. Be a vertical shrink because our value of a is 1/4. 1/4 is indeed between 0 and 1. Another nice way with fractions to be able to tell if it's between 0 and 1 is if the numerator, the top number, is smaller than the denominator, the bottom number. 1 is smaller than 4, so it is between 0 and 1. 0 and 1. 3/4, still between 0 and 1. 7/5, 7 is bigger than 5. It's not. Questions on this here? Yes? Mm-hmm. So when we look at this here, 3 to the right, so A, H, and K. Now, since we do have this x minus 3 inside, that 3 is lining up with our x minus h. Our h tells us that the function is moving to the left or to the right. And all of these are really comparing back to our parent function. So for quadratics, we're looking at the function f of x equals x squared. So this function here, how did we move it from x squared to 1/4 times x minus 3 squared? It was here, here, here. Because this here is the parent function x squared. So we're trying to see how did I go from here to the blue one? Well, we moved it 3 to the right. Because 0, 0 was our point. Now 3, 0. Then all the y values from there, we shrunk them by a factor of 1/4. So right and left is going to be the opposite of what we think, because h is going to be the value we move to the left or right, and this kind of asking how we know. So here, because x and x line up, yes? Our signs, minus and minus line up. So 3 has to be the value of h. It's positive 3. Positive 3 is going to be to the right. Yes, but inside the function it looks negative. It's the opposite of what we think. Because of that x minus h, positive looks negative, and negative is going to look positive. Mm-hmm. And that's normally one of the most questioned things is left and right. Opposite of what we think. It looks like it should move left, but it's actually going to go to the right. So we're not going to use a graphing calculator, but if we look at this here, negative absolute value of x plus 5 minus 3. So this is an absolute value. The parent function is going to be an absolute value. And as we look at this here, is there a value for k? So there is a transformation up or down. How far are we moving up or down? We're going to move down 3. Because it is minus 3, it's going to move down 3. Up and down moves exactly like we think it should. Do we have value for h? And its value is 5. Now, would we go left or right? Left. Because x plus 5 inside those absolute values, it's the opposite of what we think, because it looks like it should be to the right, but it's actually to the left. Do we have anything else? Because A is negative, yes? So it's going to be a reflection across the x-axis. Because really, A is -1. Because if we also looked at vertical shrink, well, 1 is not bigger than 1. And 1 is not between 0 and 1. There is no stretch or shrink. For there to be a stretch or shrink, we have to have a number there other than 1. And we'll never have 0 either. We covered it. That's all 3. Questions on this here? Do we feel comfortable with this here? Okay. That's it. 3 through 5, 9 through 15 odd. So 9 through 15 is odd. 19 through 25 odd. 27, 28, 31. So the odd number problems? Yeah. So you're doing 3 through 5 all. 9 through 15 odd problems only. 19 through 25 odd problems only. 27, 28, 31. So whenever I put odd or even after a set of numbers, you're only doing the odd or even numbers in that group. So, yeah. Yep. Yeah, so 3 through 5 all. Then 19 through 15 odd, so 19, 21. Or 9 through 15 odd, sorry, yeah. 9 through 15, by the way, is on the top right. 9 through 15, so 9, 11, 13, 15. Then 19, 21, 23, 25, 27, 28, 31. Yes. 3, 4, 5, 9, 11, 13, 15, 19, 21, 23, 25, 27, 28, 31, yes. By the way, guys, on 19 through 18, 19 through 26, 27 through 37, where it says graph, you do not have to graph them. I'm not expecting you to graph them. Name the parent function and describe the transformation. If you have questions on any of it, please email me.